Okay, so now let's take it up a step further and do an example with arrays. Okay, and then we're going to do arrays and functions as well. So let's go ahead and do another program, and we're going to call this one pointer review, and this will be 3.c. Okay, so let's close that in there. Let me save this as, so let me just copy this part here. I just want to be consistent with the file naming that I use, so make sure this is a .c program. Paste it here, save. Okay, so the objective of this one is the use of pointers. So we're going to use pointers with an index, and we're going to use the pointer with I'm sorry. It's the use of arrays. Okay, I need more coffee. All right, so let's get started, and we're going to keep everything in main first, and then the next version, we're going to pass the array to an actual function, and we're going to do that by reference. So then you get to appreciate an example where passing by reference does help you alter values the way you want to. So first, we're going to keep everything in main, and we'll understand the behavior of an array. So system pause, and then return 0. And let's go ahead and declare an array. So this time, int data, and my array will have 5 items. Okay, so here I declared an array. There you go. So let me save this. Okay, so that's an array that has 5 consecutive memory location allocated to this data structure. It is a data structure. Okay, so can I access it directly using indices? So yes, access the array using an index. Let's call it an index. Right, so this is your typical method of access for this one. Now, remember, in this example, I'm not going to use loops or anything like that. I am simply going to access them one at a time and do the same thing with the pointers. So the reason I'm not doing loops or if statements or any of that is it all depends where you are, whatever course you're taking. You may not have gotten into conditional programming and looping. So we want to concentrate simply on the concept of using an array, using an index with an array. How does it behave? And then how do you use a pointer to do the same thing, okay, in terms of access? All right, so for this one, you want to write to the array, for example, write to the array. And then we want to later on display the content of the array, right? So display the content of the array. So this is the main strategy. We're going to do this with an index first, okay? So the point is it's a data structure that you can write data to and retrieve data from, okay? So you can do something like this, data, index 0, it's always your first, a book that has 5 pages, and it always starts with page 0. That's why the index is 0. So don't start with 1, you would have skipped the first page, okay? Don't do that. So now I could store 4 in there. So next is data 1, and again, you can put data in there, let's say -2. Now, these are integers, so don't do a 2.3 or anything like that, okay? So those kind of shenanigans don't work here. So if you want to do that, you need to declare the float data 5, and then you can put whatever you want, okay? Or numbers with a decimal point. So data 2, and this one, let's say we put 0 in there, right? So, and data 3, and we're going to put 100, okay? And then data 4, and we're going to stop there because from 0 to 4, you have 5 items. That's it. Otherwise, you're going to be stepping over another memory location you're not allowed to use, right? So let's put a -6 right here. So let me just save all of this for now. Okay, good. Just in case this thing has frozen on me before, I don't want to pause this recording. I want to keep going. We've got a lot of material to cover. So now I want to display this stuff. Okay, you can display it by using a printf for each one. Obviously, we're not doing loops. We could have compacted all of this into one statement and be done. But that's not the learning objective here. So the learning objective is write to it and read it. All right? So, and then we're going to do the same technique using a pointer. Printf, okay? And you could say something like this, data 0 equals, and that would be a %d, so we want to know what the value will be, right? So this would be data 0. So this is how you reference to it. That's it. So it's direct, just like you did with data, except you have to use the index, okay, to be really precise as which data member out of this array you're looking at, right? So if we're doing this, and you can guess for data 1, it will be the same thing. And that would be equal to %d. It's at %d. Again, it's a placeholder for an integer, right? So data and 1 here. All right, so just to save some time here, so I'm just going to copy this and paste it 3 more times, I'm sorry. So 1, 2, 3. And this would be data 2, data 3, data 4, and you're going to do the same thing here. So this is data 2, data 3, and data 4. All right, so now is a good time to save it, compile and run. And here are our values: 4, -2, 0, 100, and -6. Okay, so this is direct access to the pointer. To the array. Now, so you can see pointers at the tip of my tongue, and with like coffee, I keep talking about it. So let's go ahead and do it. Let's go ahead and have a pointer that deals with data. So we're going to have int asterisk. So it's not any different than what you've done before, right? And call it dtptr if you want. Okay. Now this here simply declares a pointer. It's not assigned to anything. This is simply a pointer declaration. Could I declare it and assign right away? Yes, the answer is absolutely. Could I have, so who should I make it point to? Or what should I make it point to? That is the question, Mr. Watson. Well, it's not that bad, actually. You could make it point to this. Watch this. And % data 0 semicolon. The first data member. You could do it this way. This is one way to do it. And then you move the pointer accordingly. Now remember, if you have an integer, it takes 4 bytes in memory. So how do you move the pointer? By incrementing the pointer by 1, you're technically moving it 4 bytes. How does it know that? Well, it's an integer pointer. It automatically knows its own size, which is 4 bytes. That's going to be a huge advantage in terms of how we're going to traverse the array. Okay, so I could leave it this way. I'll show you this one. And let's use the pointer to see the content of the array, dtptr, right? So we're going to display the content of the array using the pointer. We know we're pointing at the first element of the array right now, right? So I will show you another technique on how to do this when you have an array. But right now, this is the formal way of doing it. So let's go ahead and do a printf. And data 0 equals %d /n. And this time, you're going to dereference the pointer. Right? So what is the name of your pointer? dtptr. Now let's see if that will appear here as our value. So first, before I do anything, let me go ahead and save and run this part. Compile and run. As you could see, where is it at? Data 0 is 4, right there. Let me put a space between them so we know. So let me just put a printf here. And put a whole bunch of /n's here, /n, right? So just so we can separate these two programs from each other, right? So these two parts. So compile and run again. As you can see, here's my 4. I have a whole bunch of spaces in here. That's your /n's. So data 0 is 4. So we're pointing to the first data member. Great. Now, how can I make it point to -2? Well, move the pointer. If you don't move the pointer, you're going to be, it doesn't matter what you do, you're going to be pointing at the same variable. So how do you move the pointer? You could formally do it this way. Star dt ptr equals star dt ptr plus 1. So I'm going to leave the formal version for this one. I'm going to show you the informal version in a minute. And okay, so now that you move the pointer, how's this going to help me find the next member? Well, you have to print it. And we're going to do this. Data 1 equals %d /n. And guess what? All you have to do is dereference the pointer. Now, the pointer does not need an index. It has just moved by 4 bytes. And let's see if that's true. So compile and run. And sure enough, I'm looking at the wrong data there. How did it pick up 5? And see, something is wrong here. We have a 5 instead of a 2. So it's reading garbage. Let's see what's going on. And we have data PTR, DTPTR, DTPTR plus 1. That is interesting. And this is an anomaly that, I didn't expect right now, so I must have made a mistake. Well, let's see what's going on. Why is it showing that? Let me run it again. Run. And it's picking up 5. I have 5 is nowhere to be seen. So let's see what's going on. So I am dereferencing. I incremented the pointer by 1. So the previous pointer was pointing at the first element. Okay. And now it's pointing at 5 for whatever reason. So let's go ahead and do this. Let me do the informal. Let me just to see if my incrementation pushed me above where I need to be. So I'm going to just do. I know what I did. I made a big mistake. I actually added 1 to 4. This should not have been a dereference. This is a good point. So let me show you where the mistake is. Compile and run. What happened is I added 1 to 5. To 4. That's what the 5 came from. I have not moved the pointer in my case. I have added a value to what was pointing at. What the pointer was pointing at. This is a mistake. You need to move the pointer, not what it is dereferencing. So I'm glad I made this mistake. So again, weak coffee this morning will lead to this. This is what you need to do. You need to move the pointer. So if anything you learn from this mistake, move the pointer if you want to go to the next data member. Otherwise, you're altering, if you're dereferencing, you're altering the value by the pointer. So let's go ahead and compile and run here. And now we're in good shape. Now we're moving to the next data member. Okay, excellent. So now let's go ahead and do the informal way of incrementing. So dtptr plus plus. This is equivalent to dtptr equal dtptr plus 1. Okay, and let's go ahead and printf data 2 this time equal %d and comma, oops, and dereference dtptr, semicolon. So let's see if that moved on to the next item, and it should. Compile and run. And sure enough, it went to 0. Again, okay, so move the pointer. Do not dereference the pointer. So you're using this to navigate through the array. Okay, what I had done before is I altered the content of the array. So this here allows me to navigate instead of altering. Now, if somebody had asked me to offset all the values by 1, yeah, then a star data PTR will have been a really good idea. Okay. Okay, so the changes are going to be done in this pattern. So we're going to do this for, so let me copy this part. We're going to do this for 3 and 4, right? So this will be for 3 and 4, and hence we have our 5 elements. So let's go ahead and see how this works. Compile and run. And sure enough, now we got our values. Okay. So speaking of which, why, you know, this gives me an idea. Let's go ahead and alter, right, the content of the array using the pointer. Okay. So let's go ahead and alter. So we're going to do that. We're going to alter the content of the array using the pointer. And what we're going to do is we're going to have to access each data member and change it. So remember, your dtptr now is pointing to the last data member. So you have to be really careful. You move the pointer. Right now, as it stands, it's pointing to the last data member of the array. So what we're going to do is go backwards now. We're going to go backwards. So we know that data PTR right now, or dtptr, is pointing to really data 4. So be really careful. So it's pointing to -6, right? The content of -6. So we're going to go backwards. Okay? So we're going to do star data PTR equals, we could alter it, we could add to it. So I'm going to add a -1 to the -6, right? So at the end, we're going to end up with -7 for data 4. So I'm going to go ahead and do asterisk dtptr -1. So that will store -7 in data 4. Next, you need to drop your pointer by 1. So dtptr minus minus, or dtptr equal dtptr -1. That way, we can alter the next data member, which is data 3. Now I'm going to do that one. I'm going to simply change it. dtptr equals, I'm going to put what was in there, a 100. I'm going to put 66. So I'm going to directly alter it, not based on the previous value. Then you need to do what? dtptr minus minus again, right? You need to decrement now, because remember, when you finished right here, by the time you got this line of code done, your pointer was pointing at the last element. You need to decrement your pointer to get back to the first element, right? So as I'm going back, I might as well go ahead and change the data members of the array at this stage. Let me hit save here just in case this freezes. So I'm going to change, so the next one is data 2, and I'm going to change it to a 1. So asterisk data PTR equals 1. You can do that. All right, so next you need to decrement again. And that would be asterisk data PTR. So what do you want? So for this one, it had a -2. Let's make it equal to 99. Then decrement again. dtptr minus minus, and that will be your last element. And then let's add simply a 1 to that one, just like we did before. So we're going to do a star dtptr equals the previous star dtptr, which is your 4. And we're going to add a 1 to it. Okay? So now, display the content of the array. And we're going to just simply copy the same code we had initially to access it directly. So, put a Y here. Okay, how are we going to do that? We're going to go back here. We're going to simply copy all of this and see if we get the same results. So copy, or we get something else, right? So because we have a bunch of, let me put a bunch of /n's here. Copy this as well. Right when we were done here, just give us some space and see what we get. All right, so compile and run. And sure enough, okay, as you can see, data 4 has a -7, right? Because you added a -1 to 6. The other one, we changed it directly, 66 for data 3. We changed that 0 to a 1, 99. That one we added a 1. So we had different ways to alter the values using a dereference. The most important part is not to confuse dereferencing with moving the pointer. Okay, so this hopefully was a good example of what to do and what not to do, and the what not to do, how to use it properly. Okay, so we ran into that issue, which is a good thing. So it's like a wake-up call here. This is what you need to do, right? So good. So